All right, in this video, I want to take a look at integration by parts when you've got a definite integral. Essentially, there's two options you have, as we'll point out as we go along here. So anyway, this integral, they got a polynomial times an exponential. That's kind of crying out. I don't know if you can hear them. They start to whisper to you after a while to tell you what to do. And after a while, integration by parts ones really scream at you. You hear them say, "Integrate by parts!" Anyway. Let's put the x right here and the e to the x there, dx. So the derivative is dx, and the antiderivative of e to the x is still e to the x. So I've got x times e to the x minus the integral of u v du, so e to the x dx. Now, if we're just doing a definite integral, we just keep going. Sorry, if we're doing an indefinite integral. Definite integrals, though, I mean, how do you do a definite integral? You first do the indefinite integral, find the antiderivative, plug the endpoints in, and subtract. So I could just keep going and plug the endpoints in when I'm done. Or sometimes what you see people do is they say, well, this part's already been integrated, so I need to evaluate it between 0 and 1. And then I still need to integrate the rest of that between 0 and 1. So you can do this evaluation right now, or you can wait until you're all done and then do it together. So this integral is equal to this. I'll do it right now. Here's 1 e to the 1 minus 0 e to the 0 minus whatever this integral is. And, well, that's an easy one, e to the x, evaluated between 0 and 1. So anyway, this is e minus 1. Oh, no, 0 times 1 is 0, so that's just an e. And then I've got now this minus, careful now because it's minus that whole thing. So e to the 1 minus e to the 0. Distributing the minus sign through, I've got e minus e plus 1 for a grand total of 1. Okay. The two options, one is what I did. The other is to say, let's not evaluate it yet. Let's just keep going and leave that as an e to the x. All right, x e to the x, and then finish the integration here. So finish this as e to the x, and then that whole thing evaluate between 0 and 1. Right? And so then what you'd get is 1 e to the 1 minus e to the 1 minus 0 e to the 0 minus e to the 0. This is 0. This is a minus sign here. This is minus negative 1. So I get 1. I mean, you get the same answer either way. But I want you to be aware that you'll see the notation both ways. Some people say, well, you've integrated this part of it, evaluate it between your two endpoints. Others say, oh, just wait till you're done and then plug in. Either way is legitimate.